I think I can go ahead and get started. So today, I'm just going to walk over and kind of gloss over this specific package for plotting. It's one of my favorites. I put a link in the description to at least a primary documentation source for this piece of software. It is a package. It's called Calplot. As I understand, you can install it with install packages Calplot. But the point of Calplot is that it makes multi-pane figures really easy to make. And so this isn't really a whole lot of nuances about bioinformatics. It's just nuances about how we can make plots look nice and easy ways to make them, right? So there's kind of a theme in computing and bioinformatics and anything else computer related. You want the computer to do as much as you can, and you want to do as little as you can by hand, right? The computer should try to do everything, and the better you get at this, the more you can make a computer work. And so I'll at least introduce plotting with iris first, using the default iris dataset, and then maybe using it for our specific purposes. So let me go ahead and load in libraries as I need. So I need my ggplot. I'm just going to work off of the terminal for a little while before I kind of revisit the script. All right. So, right, some of these graphs we've seen before. I believe I've talked about the iris dataset before. It's kind of a default built-in dataset for practicing. If we ever look at plotting tutorials, you're almost always going to see a tutorial kind of cover the iris dataset first. But right, a sepal length, sepal width, petal length, and petal length, and petal width for 3 different species of irises. Okay. So let's just kind of make a quick ggplot of sepal width and sepal length. Why not? We'll make a dot plot. Color. I gotta color it. I feel like my internet's running a little laggy today. I'm sorry about that if that's true. Change the size a little bit, make it a little bit bigger and easier to see. Okay. So right. Simple iris plot, X and Y, sepal length, sepal width. Now, kind of the nice thing about ggplots is they can be saved as an object or as a variable or anything else. So I'm just going to save this, like any other thing, as I'm just going to call it sepal. And just hang on to that for a little bit. And let's say I may make another graph that's going to be a histogram. Well, let's do X and Y on petals, right? So we also have some data on petals. So we'll just make another ggplot on petals. Another just simple G on point. No, point in T. Petal width. Man, spelling always matters. Spelling matters so much. There we go. Petal width. And so I'm just going to save that also as petals. Why not? So I have petal and sepal stuff. And maybe I'll make one more graph that's a little related, but just kind of a different thing of the same data. Let's see if I can do this. ggplot iris x. I'm just going to make more or less a histogram. So let's see what kind of what thing we can make this on. Petal seems pretty polite, so let's just do petal length. It seems to partition out pretty well. Let's see. This may look awful. We'll see. Okay, I'm gonna make this simple. Hist. Iris. Oh, AES. Let me try density one more time. Okay, almost. Okay. Alright, there we go. That's about as good as I'm going to make it. But let's even make this look a little bit weirder. Just slightly weirder. And put this on a facet grid, right? So we can have separate each species, right? We'll facet plus a facet grid. Let's see what happens on the species. See if that complains or if that does what I want. Almost. Species tilde. All right, that's how I want that. I'll leave that there, because why not? And so this is petal length, density. Okay, so I've made 3 different plots here. I've made 3 different plots, all kind of related, all kind of different. Now, what Calplot lets us do is put all of these plots into one figure. And whenever you're making a lot of figures and you don't want to do it by hand, and your boss makes you change your data all the time because you need to add a new data point, and then you have to replot everything and then fix everything over again, huge pain in the ass to just do it by hand. So it's way easier to make all of your code, make your plots, and then so if the data ever changes, you never have to change your plot. You just have to update the data points and run your script, and everything gets plotted out as it should be. Much easier. So we can do this with Calplot. So what do I have? I have petals, sepal, and petal density. Okay, so let's make a side-by-side plot with petal and sepal. So I need Calplot now. Library Calplot. And so Calplot was written by Klaus Wilk. He's at U Texas. He also wrote a book called Fundamentals of Data Visualization. Really good book, at least for how you should plot your data and what a bad plot looks like. Not necessarily like a tutorial or how-to, but really like how to make your graphs look informative, and what to do about color blindness, etc. Because RGB, not super helpful for color blindness, which isn't all that rare. Anyways, very good book, very helpful developer for R packages. But anyways, within Calplot, the primary function I use is plot grid. Plot grid. And so this is just a module within the Calplot package. But this is really easy. You can just have our saved ggplots and put them side by side. So let's have petal and sepal. So we'll do sepal and then petal, right? Because these are just what we saved. from our ggplots. And plot grid lets them put it side by side. And that's all. That's as easy as it can be. It's plot grid, plot 1 and plot 2. And they both pop up side by side next to each other. Awesome. And of course, like anything in ggplot, we can manipulate whether we want legends there or not. We can always edit everything that we want. Sometimes we want everything here, sometimes we don't. We want to update labels, change the position of the legend, change colors, whatever. All of it's fair game, but those are the details, not the fundamentals. But right, so cowplot, boom. 2 figures right next to each other. They're effectively aligned, so we don't have to worry about aligning them. They're all going to roughly have the same text size. So easy to use, so helpful. And so we don't have to have just a side-by-side plot either. We can put this on top to bottom. So we can change this. So plot grid has a few other options. Right, we can always pull up a help menu by running the question mark in the function, so we can see what other options are available. Like we can decide the number of columns. Like the default, we've decided that there's 1 row and 2 columns. That's kind of the default of this specific plot, 1 row, 2 columns. But we can change how many rows we want. We can change how many columns we want. We can change relative widths if we want one figure to be a little bit bigger than other. We can do a lot of different things with just this one function of plot grid. So for example, the default is 1 row and 2 columns, but we can certainly change that with in row and in col for in column. So I'm going to do this for where I'm going to change the in col is equal to 1. So there's just only 1 column. And then I have this other function, this other helpful tool that's align. Like, how do you want your figures aligned? Do you want to be horizontally aligned, vertically aligned, or both? So we can change this as well. So align equals H, B for vertical. And so basically, whenever I run this plot, instead of being side by side, now the one will be on top of the other. Right? So the default is side by side, but we can certainly change the position of each plot. However we want to, we can change which one is on top, which one is on bottom, things like that. And so I'm just going to call, I can even say the plot grid. So I can save this as well. So I'm just going to call this first. Why not? For no other reason, because I can't find a better word. We'll just call that first. And save that plot grid. And so then we also have this petal density graph that we made. And we can go ahead and join these graphs together. So plot grid, if we have everything we want in 1 column, we can save that 1 column as something. And then plot that 1 column with another column. So we can kind of do a nested plot grid strategy where we have one within another. It's a little bit tricky to do like 3 or more plots. There are other tools that can help you with this kind of type of plotting, is when we have multiple plots in one figure. But nonetheless, so we have 1 column made. And let's say I want this side by side with petal density. Let's just, to remind ourselves what that looks like, we'll get these 2 figures side by side. And so let's use Calplot to do that as well. Plot grid. And so I want my first and then petal density. And so this is going to be in col equals 2. And let's see what happens. I'm going to do align equals H for horizontal. And let's see what happens. That should plot out pretty well, or well enough. But let's make sure that actually does happen. You lie. Aligned unless the axis parameter is set. Well, close enough. You know what? Close enough. I got an error, but Close enough. It complained about this align equals horizontal, but I'm okay with the output, right? So ultimately we have three different plots here. I'll get rid of that align where they're side by side. So we have column 1 for one plot and column 2 for the other plot. And column 1 is kind of a nested plot. So I'm going to modify my first plot, because not only can we make a plot, we can also label a plot. So another nice thing is that we can add figure labels to this. So we can add basically an A, B, and C to each of our plots. So I'm going to do this here with first, where I'll have labels. This is also a parameter within plot grid. We have to assign it as a list. So A, comma, B. And so we save that. I'm just going to run first real quick so we can pull that plot up. And now we should have A and B labels applied, right? So now we have figure 1A, figure 2B, all side by side. Again, very, very awesome. One less thing we have to do by hand. And the less we have to do by hand, the better. So that's pretty sweet. And so I saved that as A, B, and C. And let's see, I should be able to adjust my final plot grid, because I've now saved my labels to first. I'm going to plot first. And let's see if I do labels, since A and B are already done, and I have two rows here, we'll see what happens. I'm going to leave one blank and then put C for the other. And hopefully that will work. I'm not entirely sure, but we'll find out. Labels equals. All right, there we go. That's surprisingly successful. So now I have all three of my plots individually labeled for A, B, and C. So if I'm writing a figure legend up, I can have figure 1, A point to something, B to something, and C to something, right? And basically describe what's in these figures. But nonetheless, again, just makes life so very easy when we're plotting figures out. And so let's kind of take this strategy of multiple plotting and apply it to data that we've already seen before, we've already made before. So this is we'll update our plotting at least a little bit to apply for our RNA-seq stuff. So I've kind of kept this plot or this script in the background because I didn't want to talk about it just yet. But right, this is all of the expression plotting stuff that I made for our RNA-seq things. And so from here we made like a plot MA, a volcano plot, and a P heat map. And so let's see what we can do with grid, plot grid, and see what we can make out of these three figures. So I think I need to change my session and source it. Yeah. What is this? Expression plotting. Okay. All right, and so now that makes a few more things, right? It makes our P heat map. I'm going to get rid of that because I don't want it just yet. But right, just kind of a reminder of what we've actually plotted. So we have the MA plot, and these are things that I've already made. It's just now I went ahead before class and just assigned them to a variable. So we have the plot MA, that's effectively the base mean against the log two-fold change. And making significant or not, or at least labeling something significant or not. So I save that as MA plot. And so we can just pull that up and so we can see it again. Right, so there's our MA plot where the blue dots are the significant ones and the Y is the fold change. X is the base mean expression value, right? Again, not exactly the prettiest graph. And I think plot MAs are a little bit harder to look at because we have so many data points. Whereas a volcano plot is at least a little bit easier to look at to identify the significant things. So we had the volcano plot. Load that up just to see remind ourselves what it looks like. And honestly, there's not a huge difference between a MA plot and a volcano plot. It more or less shows the same thing, just in a slightly different way. Like the y-axis in a volcano plot is the p-value. Whereas the y-axis in MA is the log 2 fold change. But nonetheless, they more or less show the same thing. And so volcano's okay, but we have this kind of outlier that really skews this entire graph, right? So it makes the y-axis almost doubly long as it, right? It's as long as it should be, but we can get 99.9.9.9% of our data into one figure and stretch it out a little bit better. So I'm going to change the x and y on this real quick. I should be able to do this. We'll see what happens. I'm going to set it to 15. All right, all I'm doing is changing the Y limit so we can see this plot a little bit better. We can see more of the data. It's less compressed. It's less smooshed and more expanded. So I'm just going to leave it at that and ignore that one outlier data point just so we can see this a little bit better. And so now we have two plots. We have a plot MA and a volcano. So we can certainly plot those side by side with plot grid. So let's go ahead and just do MA plot and volcano side by side. There's just so many data points. It seems to take a while to do. Okay, yeah, same, more or less. That's fine, right? We have a plot MA and a volcano plot right next to each other, and so we can kind of, again, it more or less presents the same data in just slightly different ways. The x and y's and the change, but nonetheless the significant values are just colored, or the significant differentially expressed genes are just colored blue, right? And let's have the last one. So p-heatmap is a little bit trickier because p-heatmap isn't inherently a ggplot, right? So it's a little bit different. So I'm just going to run all of that just to bring up the p-heatmap, the raw p-heatmap. But again, it can be saved, right? So we can save a p-heatmap in some degree to a variable. But again, this just shows our differentially expressed genes, what's up, what's down, in what treatment, right? And so I did go ahead and save that as a variable. And so Calplot and p-heatmap, they kind of go together and they kind of don't go together. If I just do if I just try to throw in p-heatmap into plot grid, I'm going to get an error. And so I'm going to stick with the volcano because I just think the volcano is a little bit easier to look at to see our biases and what's significant, how significant it is. But let's just see what that looks like. P-heat and volcano. I'll do volcano first. And so I should get a complaint. $1 says it will complain. Yeah. So again, p-heatmap's kind of compatible. It's kind of not, right? So we get the volcano plot, but we don't see the P heat map. But there is somewhat of a hack to it, because the figure itself is really stored in like this fourth component of the P heat map. And so we can straight up extract that figure. Again, it's a little bit wonky. It's not because I necessarily know this. It's just because I Googled it and Google gave me a solution. And that solution was to put number 4 between two sets of square brackets. Because what we're kind of doing is physically extracting the figure itself from this P heat map object. And so that should at least work well enough so we can get a volcano plot and a heat map side by side. So that's pretty neat. Again, it's more or less showing the same data in a slightly different way. So we can see that where the log fold change mostly is. And we can demonstrate that in 2 different ways. In a volcano plot, that shows most of the fold change is positive. So it's going to be, most of the time we're seeing a down regulation of expression. So we're seeing genes being lower expressed in a saltwater treatment. And so you can definitely see that better in the if we're confused by the log fold change, we can at least plot it side by side with our P heat map that directly shows the fold change, what's higher and what's lower. Now, of course, if we want to take this another step further, we can label this A and B. And so I think we'll see where P heat map and plot grid aren't super happy with each other. All right, because we get this B being thrown out within the heat map, and so to me there's not an easier change than to actually like export this as a PDF and move that B up, right? So kind of works together, kind of doesn't work together, but nonetheless still way faster than trying to get these 2 things plotted together by hand in, say, Adobe Illustrator or Inkscape or something along those lines. Again, just the nice thing of plot grid and ggplotting is to just save time and make our computers do as much as it can without having to do anything by hand, or minimizing how much we actually have to do by hand. And so again, as you move through your academic career, if you're going to go to grad school, if you're going to stay in grad school, whatever, you go into professional school or a professional career, this is definitely something you can take with you. Like RStudio, ggplot, and Calplot, it doesn't matter what discipline you're in. It really does not matter, because you're going to have to plot your data out. And plot grid, between ggplot and Calplot, you can make some really pretty figures really fast and not have to do anything by hand, right? You don't have to worry about accuracy. You can just let your computer be as accurate as it can. Right? I know all the bioinformatic tricks won't really follow you that much into your careers, but certainly plotting certainly can if you stay in science. Right, so we all have to present our data. It's way easier to look at than numbers. So keep that in mind as you move through your academic and professional careers. To let R do as much for you as it possibly can. Right, these aren't the only plotting packages. These aren't the only ways we can plot data out. But these are very, very convenient tools. All right, and so for my class, this is the last lecture I'm going to make. At this point, more or less, I'm just going to set you free for the rest of the semester. We'll talk more about it, but you're more or less set free to play with your expression data make some plots and describe what's happened. But for, this kind of message is for everybody else that's either subscribed or has watched these videos at some point through this semester or anytime. So most likely, fingers crossed, classes are going to be in person from in the fall, and from that point forward, assuming something else doesn't go horribly wrong. So I'm done with YouTube. This is the last video I'm going to make and post to YouTube. But nonetheless, all of the stuff that I made for this course is going to stay here. So all of it really is just kind of approaching the basics or the fundamentals of some tools for phylogenetics, gene expression, and annotating purposes. Right? There's certainly more to bioinformatics. There's certainly more to biology. But we certainly haven't gone into really crazy computing. We haven't really programmed in anything except R in RStudio. But nonetheless, fundamentals are there. So again, I'm done with YouTube. I do appreciate y'all subscribing and watching whatever may be valuable to you. If there's something you want more information on, I may make a video for y'all, but otherwise I'm effectively done doing this. So I'm gonna log off now, and the rest of my class, I'll give you directions in an email later today. So I hope you've enjoyed this to some degree, at least seeing what we can, all the crazy things we can do with a computer and how much a computer can save time in our lives. So we can do, the more you can learn a computer, the more you can do in biology, quite honestly. So I hope it's at least been entertaining and reinforced what you've already learned in your core biology classes. So until I see you all in person, I'll talk to you later. All right, take care.